I was playing this game, Going Balls, and this life counter. UI mechanics attracts me. How this pickup animation, how when you die, you see that the UI updates, that you lose one life. Let's see. So I will replicate this small logic in my game. So there is my game. There is the UI with my style. I didn't implement the lose, but I implement this small wall. When you collide with it, you lose one life. But in my case, I made the image to fade out, not another sprite, with like a X in the Going Balls game. So they are all. So I lost 4 life, and there's the pickup. This is just a small sphere, but I could change in the final version, like this one, and you see the UI update with small animation collect. There is it. Now all my life count is filled. So let's start with the scene setup. Then after that we will go to the code. First of all, like you see, we have right now 2 canvas. There is the second canvas that hold this logic, and if we zoom on it, you will see it. There is it. There is the canvas. I made the render mode to screen space camera, so it can render on top of all of the thing. Then we have a vertical layout group. This vertical layout group, it will hold all the side. There is it. This is the gray background with a canvas group for the alpha to have access to the alpha value. Then we have 5 images, sample images. If we delete like 1, you will see the layout groups automatically update. But we only have 5. Excellent. So the setup of UI is not a complex thing. Just another canvas, and you must not make it a side of the root canvas, because this canvas with a lot of other canvas aside, it becomes very heavy. So we need to decouple the workload of rendering to have a faster game. So this is why I made a second canvas. And another purpose of having a lot of canvas, you can have each canvas with different render mode. Like here, you have the render mode of screen space overlay. So let's go to the code. There is the code part. I didn't use another script. I just stay in the menu manager script. I want to make all my UI logic in one script. So there is the added variable. The first variable, so we can have a reference for the new canvas. Like I said before, the canvas group for the alpha value. Then we have 2 game objects. One, the parent that contains the vertical layout group component. Then another game object for the UI image, because when the player collides with this object, we associate a small sprite that animates with the destination, the background, then it disappears. So we need to have a reference of the object. Then we have a list of game objects for the 5 sides of the vertical layout. Why? Because we need the reference of each position depending on the index, because the end position of the animation is dynamic. Then a private int for the number of life the current player have, because when he is equal to 0, that means 0 life, then that means the player is losing and he needs to restart the level. Then the reference to the main camera. In the awake, we make the parent vertical layout group to vector to 0, so we can have the animation of the scale. Then we go automatically in the menu. So up is the moment when the player press play to start the game. Then we need to make the canvas. No, it's the opposite. The moment before the player press play to start the game, we need the canvas to be set active to false. But here is the moment when here the moment when the player press play. So the menu canvas go and the in-game canvas come. We make it true, then a fade to a value of 1 alpha, so that means it's visible. Then we do a do scale of 1, so it give us the pop effect. There is. We press play and voila, this a small effect animation. We continue the code review. Then we go down. Here first we have the destroy life and regain life. This logic will be implementing when the player fights with enemy, and this logic of the player when he pick up the collectible. It's the pink sphere like you saw before in the beginning of the video. So like always, we check how many life we left. If we have minus of equal to 0, that means all the life faded, and we return. So that means the game is already finished. Then we have a local transform child that take the transform of the child of the parent in life icon object. And because like I said, the dynamic index, we use the number of life minus 1, because in the hierarchy we start with 0, but number of life it's an int variable, it starts from 1. Then there is the image component, we get it from the side. Always a simple check, if it's different than null, we make a do fade of 0. And we don't forget, we decrease the life. There is it. Always I show you the code, then the real simulation, so you can catch up between the code and the logic. So there is it. Right now, imagine the pink wall is an enemy. I collide with it, and voila, I lose a life. With feeding, another attack, and voila. So we return the number of life. Then here the complete opposite. If the number of life is equal to 6, we return. So the player is already full. We cannot add another life. Like always, we need to get the transform of the side with the corresponding index. Then make the image to 1. So that means he recover his 1 life, and we increase the number of life until it reaches 6. Like I said, first of all we lose a life, then we go pick up another. There is it, and voila, the animation then the current image show up. Excellent. Now the first two logic are sound. Now we go to the animation logic. The animation logic is quite tedious, but I will explain it in detail. First, this function need a parameter that is a transform. Why this parameter? Because the player, when he collide with the collectible, he will extract the collectible transform. then local vector tree variable that take the word to screen point. So that means the collectible word position is in the word space, but we need to convert it to the screen position. Why? Because the canvas is in the screen and the animation, it will happen in the screen. Then a local rect transform with the name of canvas rect. It will hold the value of the current canvas, the second canvas. I name it in-game canvas. This is a local vector 2 that will hold the value, because in the rect it contains only x and y, because it's a 2D sphere. Then we use this utility of Unity, the rect transform utility, that take, like I said here, it converts the screen position to local canvas position. So in order to animate the UI in the canvas, we need to convert it from the screen position to local canvas position. It needs the reference of the canvas with the position in the screen position, the camera, and this value, this local variable, will hold the screen position. Excellent. Then there is the object that will be spawned. I name it icon go. In order to instantiate, we need to have the reference of the image, and the position is the rect, the canvas. Then we need to have the current spawned object rect transform. Then we will affect it the anchored position. Some will ask why we didn't make the anchor dot position, because the difference between the anchored position and the position like this. Give the spawn object the position extracted from the UI local post to his own local position related to the parent anchor, because the instances object is assigned of the parent object that is the canvas. So in order to have animation that work fine, we need the local position relative to the parent anchor. So we work with the anchor position, not the position, because the icon rect position, it work in the 3D world space, and we are in the local canvas space. Then the local scale to 1. Here we need to set the destination. The destination is one of the side depending with the index of the parent vertical layout, and we get the get component rect transform. Then we will use the icon rect do move. Like I said here, even using the anchor position is best for UI animation. I feel the move work fine for my case, and it work with vector 3. So I use to move. There is the function. It returns a vector 3 that hold the position of the corresponding index with an duration. Let's make it 1 second. With an is out cubic, and when it's incomplete, we destroy the image. Like you see, I didn't use a sequence because we will only have one event animation, is the move. If we have another, we will use the dot win sequence. Here there is the vector 3 method that returns the word sensor vector 3. There is his name, and the purpose of this vector 3 is the extraction of the position of children of the vertical layout group, because their value are overridden by the parent. There is it. There is the canvas. Like you see, the value driven by the vertical layout group. We cannot move it, the is x and y, but the parent objects, it's what the value are driven from. So there is the component vertical layout group. We only check if it's null and the index is between 0 and the side count. Then use the transform get side method, and we got the rect transform component of the side with the respective index. These are method for the corner because we need the exact position of the side. Some want the middle center, some want the corners, but in my case I use this method to have the center, the middle center. Here, and sample access to the camera reference used in the canvas with the screen position like the known method word to screen point. This is already used before. We sense from the screen position to local UI position, and we give it the local position. Then we will return the word center. So there is. So when we return the position of the side, here we animate the destination with, like I said before, in duration of 1. So the code is not, it took me time to make it, but I am happy I replicate the same effects in the game. So there's play collide with attack, for example when you implement it with your enemy, and there's the pick up. You can add a lot, and some will ask why it move like a little bit away, because the camera move with the player, and the moment you pick up, the player needs to stay idle, because if he collects and move, you see it move to the previous destination. There is one of the controversy when you have the canvas render mode to camera and the camera is moving, so that is a problem. But don't stay very focused in small detail. The important is the effects work, the animation work flawlessly, and even if a bug happen, it will not affect the core mechanics of the game. So stay tuned for the next video and be happy, because we will live one life. And let's meet in the next video. Subscribe, comment and like.